Alright, I'm going to work some of the problems from 7.3, all about just simplifying radical expressions, and I'm going to start with number 12. We'll do some of the more difficult ones at the end. Okay, so we start off with a fourth root, okay? And so fourth root just means there's something that can be multiplied by itself 4 times to equal 162. Okay? Well, 162 isn't a perfect fourth root. Okay? So what we have to do is look through our list of fourth roots and see if there's anything that we can take out of 162, for example. So you think about numbers raised to the fourth power. So we're looking at integers. So 2 to the fourth power, that would give us 16. We do 3 to the fourth power. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, and we could go higher, but we're going to surpass 162. So 81, we'll look at 162 divided by 81, and that gets you 2. And so what we're doing is we're splitting up 162 into 81 times 2. The reason that's helpful is because 81 is a perfect, we can take a fourth root of that and come out with a 3. And then we also have m to the 6, which we'll deal with in a second. So fourth root of 81 is 3, comes out as a 3. Okay, so think about what we're doing here. If we want to get rid of something to the fourth power, we need to take the fourth root, okay, which means we need to take the fourth root here. The fourth root and the fourth power cancel each other out, and you get 3 equals the fourth root of 81. So anywhere you see the fourth root of 81, that's a 3. Okay, same number. Alright, so the 3 comes out, and we have the fourth root of 2 times m to the 6. Okay. Well, how do we get rid of the m to the 6? If we have an index of 4, then that means we can take out 4 of a variable at a time. Because what this means is you've got 3 fourth root of 2. So I can take out 4 at a time, right? And how many would be left over? That's m to the 4th and m squared. Okay? So again, fourth root and fourth power cancel each other out, and so this is going to come out front, and it will be 3m times the fourth root of 2m squared. And the reason we took out the m is because the index needs to be bigger than the power inside the root. Let's look at 13. 13, it's a square root this time, and so we're looking for perfect squares instead of perfect fourth powers that will that we could take out of 216. So 216 itself isn't a perfect square, but 36 is. Okay, and so you'd be looking through your list and you'd find 36, and so the square root of 36 times 6, 36 times 6 is 216, and then p to the 4th. Okay, so the square root of 36 is 6, square root of 6p to the 4th. Now let's look at that p to the 4th. We can take them out 2 at a time. So how many 2's could we get out of 4? 2 of them. So we can bring that out as a p squared, but let's look a little bit closer at another way we could look at this. So split that p to the 4 up into the pieces that you can take out. So I can take out a p squared. And then what's left over? A p squared. Okay, well I can take that out too. So this p can come out front, and this p can come out front. And they come out as a p squared, square root of 6. Alright, let's move on. We'll do this. Alright, let's do number 14. I'll do the evens from here on out. 14, 16, 18. Okay, so now I got a fifth root of 224. Okay, so I'm looking at things that are raised to the fifth power. So like 1 to the 5th is 1. That doesn't really help us. My slave keeps writing on the board. and 2 to the 5th. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And we're not going to be able to manage a 3 to the 5th. So 2 to the 5th is 32. Can I divide 224 by 32? Sure can. 32 times 7 is 244, and we have n to the 5th. Okay, so the 5th root of 32 is 2. So that comes out as a 2. Then we have the 5th root of 7 n to the 5th remaining. How many n's can I take out at a time? I can take out 5. Okay? So the 5th root is saying what number multiplied by itself 5 times would equal n to the 5th. And the answer is n. 5 n's, n to the 5th. Okay, so that whole thing, the n, is going to come out front, and it'll be 2n times the 5th root of 7. Okay. 16. Square root again. So we have 256. You take the square root of that. Oh, cool. It's a perfect square. 16 times 16 is 256. Okay, so that 256 comes out and it becomes 16. The square root of xy, okay, x and y are both raised to the first power, and the index on our root is 2. Okay, so they're already smaller. We can only take out 2 at a time, and we don't have to. So we have to leave them, and the answer is already up there. And then the last one, we got the 4th root of 108. No, 3rd root of 108. Okay, and so we look at our perfect cubes again. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And I can't do the 64. 108 doesn't divide by that, but it does divide by 27. So the cube root of 27 times 4, m n to the 4th. So I can take out that cube root of 27 as a 3, leave behind the 4m n to the 4th. Okay, m is raised to the first power. I don't have enough to take out, but n's I do have enough. So let's split that one up into things we can take out. An n cubed, and how many are left? There's one more n. So this n right here, take the cube root of it, 3n times the cube root of 4mn. And that's that.